Hello again. Okay, so this question here is from 9.2. This is technically number 12. So we're kind of getting towards the ends of things. And we didn't actually see an example like this. So I'm glad that we're going to go over this, even if it is briefly and on the computer. But all the data that we saw when we were computing the confidence intervals for means, we had we had summarized data. So we had what the sample mean was. We do not have that here. We just have raw data. So I wanted to make sure we at least went over this a little bit. This is not, just a little spoiler alert, this is not a question that is going to be on the exam, but it's still good to be able to do this. Okay, so first things first, I went ahead and opened up the data right into StatCrunch. Okay, if you use your graphing calculator, you can do that way as well. Okay, and then what we're going to do is we're going to go to stats, and then again, what we need to click is T-stats. So just to kind of go through this, let me actually read it. It says the following data represents the pH of rain for a random sample of 12 rain dates. A normal probability plot suggests the data could come from a population that is normally distributed. A box plot indicates there's no outliers. So I feel like this could be kind of confusing to people because it says like it's probably normal, but everything in 9.2, we're not really sure if it definitely is, the population is normal. It could be normal, okay? But the sample size is not big enough. So we're just gonna go stick with T-stats and then one sample, and the difference this time is we have with data, okay? And then we can select variable 1, and then we'll change it from hypothesis test, which might sound familiar now because if you've checked out 10.1, we saw some stuff in the hypothesis test. Now, this is where it gets weird because I thought I was losing my mind the other day. We have had issues, and I don't know, I actually sent a help ticket to my math lab. I don't know why this is happening, but what you want to do is you want to click to store in the data table, because the other day we were having issues. We were not like, I don't know if you guys, some of you guys are doing different things at the time, but when we were using this, we were getting some different answers depending if we had it stored in the data table or not, which is very weird. So long story short, you want to click to store it within the data table. And then the lower limit here, that's like the lower bound on the interval, and this is the upper bound. Okay, so then we click, this is confidence intervals. The other two are different interpretations that we've had from previous problems, not confidence intervals. Okay, so I could be a couple of things going wrong there in terms of if you didn't get this the first time, but it is really weird. Let me know if you guys have this too, where I had to click to store it in the data table. I'm gonna go ahead and clear that part out. And I'm gonna do this again, but with 99% confidence. And the reason I had cleared it out is because if you kind of keep it in there, it gets a little funky. It'll add it on to the end, and it's kind of hard to tell like what's what. Okay, so then I repeated it with 99% confidence. And then also there is a 99% confidence that the pH is between 4.73 and 5.34. Oops, I added a little something extra on there. Okay. And then lastly, it says as the level of confidence, I'll say lastly, but who knows sometimes. As the level of confidence increases, okay, so as you get more confident, the interval, let's see, also is going to increase, right? The interval got bigger. It went from like, and I like to think sometimes like to draw this out, you know, I'm a visual person. So here's 4.82, like the original one, and to 5.24, but then the new interval that we came out with 99% confidence was from 4.73 to 5.34. So it's bigger. Okay, so if you're ever in doubt, just do a little sketch. It says the width of the interval increases, and then we'll just say this makes sense since including fewer numbers for consideration makes it more likely one of them is correct. Including more numbers for consideration makes it more likely one of them is correct. Yes. Okay. So, you know, they get a little wordy there. But the bottom line is that if you want to be more, you want to say you're 99% confidence, you're going to need like a bigger window of possible values. Versus if you're 95% close, you don't need like you can make that window of possible values a little smaller. Okay. So hopefully that was helpful. Again, I know I'm sorry that was fast, but that was 9.2 number 12. And again, it is very weird. Let me know if you guys see this where we had to click. First of all, you always need t-stats for these problems because we don't really know for sure if the population is normally distributed or not. Even if the sample size is, we still have to double check. Okay, but I had to click to store it in the data table in order to get the correct value, which is very odd. And I'm not really totally sure why. Again, I put a help ticket in so that they could see like, why would the values change if you stored them here or you read them off of this little table? But so just to be safe, click store in table and then read them off of there. All right, thanks class. Keep me posted on how you're doing, what else I can make for you guys.